Hello everyone, welcome back to Mindspread, a channel dedicated to making knowledge more accessible to everyone. Have you ever struggled in maths? Well, consider taking that frustration out on the subscribe button, because in today's video, we're going to be discussing logic, which is the foundation of all maths, and it's technically what should have been taught at schools first. Okay, before we get into it, let's go over the important rules of last video. Rule number 1. Sets are represented by capital letters. Examples are given in the orange box. Elements are represented by lowercase letters. Again, examples are in the orange box. The weird looking E symbol means element of. An example where that's used is given in the in example section of rule number 3. And rule number 4, those two symbols you see in yellow are known as empty sets. Those are sets with no elements. Okay, let's move on to subsets. First, let's redefine what a set was. A set is a well-defined collection of objects. Hence, a subset is a set that exists within a set. It's the subset of a set. Let me give you an analogy. Take the exercise known as the bench press. Well, let's call the bench press a set, a well-defined collection of objects. And those well-defined collection of objects would be the weights and the bar. I mean, like, it's no secret you need those two things to do the bench press. But a subset that could exist within that set would be the laws of physics that allow the bar to take on its shape. So the laws of matter that allow the bar to take on the shape it does, and the laws of gravity that allow the bar to actually have its weight. Those would be subsets. A more general example are given in the two white boxes. The picture on the right is not a subset, and that's why there's a line through the subset symbol. It's not a subset because A and B are not, or A or B are not fully within one another. In the picture on the left, A is fully within B, which makes it a subset. Think of subset meaning contained in or in. Now let's try a mathematical example. Remember integers? Those whole numbers that are negative and positive, including 0. Well, if I call that Z and Z plus the positive integers, so those are 1, 2, 3, 4, all the counting numbers up till infinity, then Z plus is a subset of Z, or the positive integers are the subset of all integers. Now, two more important rules. An empty set is a subset of all sets. So an empty set is a subset of any set basically. And that's because there's no elements of the empty set that are going to be missing from any set that exists. I hope that made sense. I don't fully understand that rule either. Okay, also, if A is a subset of B and B is a subset of A, then A is equal to B. Because if A is contained in B and B is contained in A, they're basically the same thing or equal. Let's try some examples. Let A be the set which contains elements 1 to 6, B the set that contains 2, 4, 6, and C the set that contains 1, 2, 3, 4. Which of the statements below are true? Well, A being a set of B is not true because not all of the elements of A are inside of B, as you can see in the question. B being subset of A is true, but because all the elements of B are inside of A. C being a subset of A is also true because all the elements of C, which are 1, 2, 3, 4, are also in the elements of A. So 1, 2, 3, 4 is also in A, so that makes C a subset of A. A not being a subset of B is also true because not all the elements of A are in B, so therefore it's not a subset. It's basically the exact same answer as the first statement. A not being a subset of C is also true because not all the elements of A are in C, and C not being a subset of B is also true because not all the elements of C are in B. Okay, another important rule. A is a subset of A, which basically means every set is a subset of itself. So it doesn't matter what set you have, it is a subset of itself. That's a mathematical rule. And just as reinforcement at the bottom below, I've got the empty set being a subset of every set as well, which is highlighted green at the bottom left corner. Now for a slightly different example. Example 2. Let A be the set that contains element x, where x is an integer, which is less than or equal to 5. Which of the following statements below are true? The correct answers will appear in green and the wrong ones in red. Well then, 3 is an element of A because it's less than or equal to 5. 6 is not an element of A because it's greater than 5. 8 is not an element of A. That statement is true because 8 is greater than 5. 3.6 is not an element of A is also true because 3.6 is not an integer. 5 not being an element of A is false because 5 is an element of A because x has to be equal or less than 5. And minus 8 not being an element of A is also false because minus 8 is less than 5. And it's also an integer. Okay, now for the last part of the video, power sets. Power sets are like those guys at the gym that are fully hardcore, taking steroids and everything. They go to the gym and probably do every exercise possible to gain maximum gains. In the same way, a power set is basically all the possible subsets that can exist within a set. I'm going to give you an example. If A is the set that contains 1 and 2, P of A being the power set of A, then P of A, which is the power set, is the subsets 1, the empty set, which is given the two squiggly lines with nothing in them, the set with elements 2 in it, and the set with element 1, 2 in it. And those are all the possible subsets that can exist within A. And that's a power set. We're going to look more into them in the future. Okay, if you made it to the end of the video, congratulations and well done. I mean, like, it takes dedication to sit down and actually study maths hard. So you're putting your foot in the right direction there. Yeah, just that, and also consider subscribing because your subscriptions is what helps me continue to make my videos. Thank you all for watching, and I hope to hear from you and see you soon. Also, if you go down into my description box, I've got a website I'm running. On there, I'm currently teaching psychological interventions to help with stress, depression, and intense emotions. So maybe take a read of that because who knows, you might be able to use it for yourself one day or maybe help someone else one day. Or if you are suffering yourself, it might help you.